On this week's Big Data and Brews, we're taking a look back at some of the big data technology architectures we've seen diagrammed so far for a special How It Works episode. So grab your brew of choice.
Cheers. Cheers. Yeah. Cheers.
Sit back and enjoy.
So a lot of our customers really struggle to just getting data together. And as you just described, I think what's so fascinating is everybody wants to do the in-memory, machine learning, real-time stream. It sounds really attractive, right? And I'm sure it makes a hell of a resume if you have the checkboxes.
Yes.
But I think the big value really in a lot of companies is just really bringing the data together and getting a 360-degree view of your process, of your customer, of your behavior.
Yes, absolutely. So if I could use this.
Yes, please.
Right? So traditionally, let's say you had your enterprise data warehouse. Okay. And I was doing some batch or bulk analytics on that. Let's say the simplest one is I'm doing a simulation for a fraud scanner.
Mm-hmm.
Because I've developed a new rule that says if this, and this happens, it's a fraud. But just to make sure there are not a lot of false negatives and I don't make all my customers angry, let me do you're traveling.
Right. So let's not talk about credit card companies. But so with my bank, that happens quite frequently.
Okay.
So I guess they should use cascading.
Change your bank to my ex-employer.
Okay. Okay.
So the aim is the more you can run your simulation on historical data to check for false positives, the better you'll know what the state is. But at the same time, you've detected a new attack pattern. And time matters. So the more time it takes for simulation, the more time that fraud is happening as well. So you have an enterprise data warehouse, and there is this much data fits on it.
Yeah.
And let's say it is 3 months worth of data. And this takes about 24 hours or maybe 14 hours to run the simulation on that.
Oh, and meanwhile, you're bleeding money over here.
And meanwhile, you're bleeding money because you want to maintain customer relationship and the trust that you're not taking a kayak trip in Papua New Guinea and you try to swipe and it's like...
Oh, sorry.
Yeah. So the first set of use cases where I believe the big data makes a very interesting play is that this is 3 months. And let's say this takes 12 hours to do.
Right.
Move this to Hadoop. So the first thing is, what if instead of 3 months, you can run it on 12 months?
Right.
The data doesn't fit in enterprise data warehouse, but now it can if it moves over here. And on top of that, instead of 12 hours, if it takes, let's say, 3 to 4 minutes to do it.
Oh, wow.
It's a very simple query. It's not machine learning. It is porting your existing queries written in PL, SQL, or whatever over to big data.
And that's a Hadoop environment.
Yes, that's Hadoop.
And the color of that data warehouse was red or blue or
the ticker symbol was.
I mean, the reason I'm asking is I would expect that a big financial services company that has a credit card has an unlimited credit card and can just buy more. What was the technical challenge to not scale that out further? Was it just limited hardware capability?
Yes, exactly.
So you just hit the maximum limit on hardware.
Most of the enterprise data warehouses, despite the investments that are made very quickly, and this is not just specific to the organization where I was in, but in talking to enterprise companies, they end up hitting their peak capacity to support SLAs very quickly, within a matter of the plan for 4 years, it's happening in 2 years. So to say I'm going to run that query on 12 months worth of historical data instead of 3 months, and this is a very simple query. The second one that the example is, I'm trying to develop a new fraud algorithm, and the data, let's say there's a source system, like let's say, let's just use, oh, you guys made it wet too, nice.
It's like in my old school.
That's right. Wet sponge, huh? And
that's the only thing we had in East Germany. And a big ruler that we gotta.
Oh, that's right. Okay, so the source system, or you can call this any one of these sensor systems, and this is not specific to machine learning, and these days the Internet of Things is a big deal. It's sending a lot of data. A lot of data doesn't just mean the speed, the pace, but it could mean it's sending thousands of attributes.
Yeah.
Or variables, depending on the
on an
complexity of the
individual
system.
user.
Yeah. Let's say there's an event, swipe, or whatever, native plus derived variables. Going over here, there's only limited space here, and only the post key variables are kept here. But the other one is, what if I could keep additional variables to improve my algorithm?
Right.
Again, we're not going into machine learning, and it's not just one. If I do a join, what do I do? If I do a join with another data set over here, it becomes really expensive.
Yeah.
Right?
Yeah.
And so the breadth and the depth, just moving these over there is the most immediate impact. You can show a quick ROI for that and then take it from there.
What's the secret sauce behind all of this? I mean, you touched a little bit that you built this in from scratch, but where's the magic of MapR start, and where's it pulling it all the way through?
Yeah. Well, maybe let's use the whiteboard here.
Yeah.
And look at what is the MapR distribution? What is the overall architecture, right? Yeah. So, it all starts with maybe I'll move out of the way so it's easier to see. It all starts with a collection of over 12 different, maybe 15 even now, open source Apache community projects. So, we have things like, we have Hive here, Pig, Flume, we just announced Yarn. So many different projects here, and these are just a few of them. There's Zookeeper and Scoop and Stinger, Tez coming into play. You can run Impala on the platform. That's part of it as well. And what we do is we've added our own data platform. So underneath here, you have the MapR data platform. So this is, I'm going to call it MDP here for short, but it's this is the MapR data platform. And what this is really is two things. First of all, it's a distributed file system, and it's also a NoSQL database in one, right? So think of this as, we could call this, it's going to be hard to see, but we could call this MapRFS here, and MapRDB here. But really, it's a single service. So files and tables are integrated. They're part of the namespace. They're protected in terms of snapshots and DR the exact same way. So it's one process running on every node. That's the MapR data platform. From a file standpoint, it's fully read-write. So you can you don't have the limitations you're probably aware of with HDFS, right? So you can modify files. You can do concurrent reads and writes. And then we also expose that through an NFS interface. So if you look at the interfaces for the MapR data platform, clearly we have of course, the Hadoop file system API, right? So that's the Hadoop file system API. And this is the same API that's exposed by HDFS or Amazon's S3 implementation or Google Cloud Storage, their integration with Hadoop. And we also have an NFS interface here, which is the standard storage interface. And customers use that extensively for everything from loading data into the cluster. So they could, for example, maybe export data from, a lot of our customers, they'll export data from Teradata using standard Teradata utilities, right? Or they'll use things like R and SAS. And because we expose a standard file interface, just like any network attached storage, you just mount the MapR cluster and you get one giant NAS. That's it.
Wow, that's cool.
Yeah, and I was actually, before coming here, I was watching a video you did with Eric Nachbar.
Yeah.
He described how he was, the reasons he was using MapR, and he loved the fact that this was kind of for him.
Those integration pieces are so critical for customers, right? If you go to a customer and say, oh, great, well, we have this magic, cool storage thing, and by the way, you have to write a few Perl scripts and some Java to get data in, they look at you like, oh, okay. It's just like 20 years back. Rather than, step forward.
It's kind of analogous to, what would you rather use to keep your documents here? Would you put them on FTP server or would you put them in a network attached storage, right? I mean, it's obviously a lot easier when you don't have to kind of use a tool to get data in and out. Right?
Yeah.
And then there's the HBase API, right? Because that's the standard interface in Hadoop for tables, right? So we expose that, and that's the way you basically read and write to the tables.
Yeah. Okay,
right?
cool.
So that's kind of the overall. We add our management innovation as well. So this is management. We call this the MapR control system. But yeah, that's kind of what it is. And the nice thing here is that there's so much innovation happening here at this layer as well. So you'll get projects like Spark and Shark and MLlib and Yarn and Hive and Pig, and I could go on and on with all these different projects that are either in the distribution or coming this year as fully supported projects in our distribution. And then we add our own innovation that provides value beyond what you're able to get, and actually kind of broadens the use cases that are possible with this platform.
So my understanding too is that the MapR file system, you guys completely rewrote, also in a different language than the Hadoop distributed file system, and I think you guys had some DNA there. So it's not the first file system that your core engineers wrote. Is that kind of the story of MapR?
Well, that's one of the things we've done, right? So I think we invest over 50% of our engineering at this layer, but we've certainly done a lot of innovation here very early on too. And Srivas, MC Srivas, our CTO and co-founder, he actually came from Google, where he was on the Google search and big table teams, kind of driving that from within Google. And Google, as we all know, is kind of ahead of the game here when it comes to big data. So he had that experience of running MapReduce and big data at scale at the best place possible, right?
Yeah.
And then before that, he was at Spinnaker Networks, which was acquired by NetApp and did their clustered file system.
Great.
But yeah, I mean, it's this combination is really what we're excited about in terms of expanding the use cases that are possible with Hadoop.
So, how is Pivotal composed? What are the layers and what are the tools? Maybe you can put it a little bit. Let me put the beer on my side here, so I have it handy.
Yeah, sure. Okay. So at the bottom layer, of course, is HDFS.
Yeah.
Right.
And it's native HDFS.
It's native. It's absolutely. It's basically open source Apache HDFS.
Yeah.
Of course, now there is a whole movement of Hadoop compatible file systems, and there are some from our our parents, in particular EMC. And so we have support not only for open source HDFS, but for other scale-out file systems like Isilon and soon to be object storage system called Viper. Right?
Oh, cool.
But it's all really from the application point of view.
Doesn't
it just
matter.
looks like HDFS.
Yeah. Okay.
Right? Okay. So that's basically the thing. Obviously, you have the whole MapReduce stack, which has Hive. Okay, I'm now going to turn 90 degrees.
Yeah.
So
good.
Hive, Pig, Mahout, etc. So that's one stack. Okay, and obviously for all of these, like other distributions, we have our own installation and configuration manager and a monitoring and management system that we call as the Pivotal Command Center, right? That manages this entire stack.
Yeah.
Okay, so the two big additions to this stack that we did over the years is first thing that we call which is called Hawk.
Yeah.
Hawk, as I said, is Greenplum database running on top of HDFS. Now, as part of, since we took the Greenplum database engine and ported, execution engine, and ported it on top of HDFS,
So this is Greenplum, right? This is
Greenplum
the
database.
loved Greenplum that is incredibly fast, that has
Absolutely.
security, that has monitoring, that has
Everything,
all the
yes.
tool integration.
yeah.
Why wouldn't I use that instead of something like this or one of the many wannabe Hives?
You should be. That's basically the thing, right? I mean, earlier we used to say that performance is our sort of main distinguishing factor, right? But really, the whole ecosystem of tools and the connectors from outside of Hawk.
There's Tableau running on top of that. There's this running on top of that and that.
Yeah.
And Informatica pumps in data.
Right.
So you basically you have Greenplum, and you can basically say, I replace Greenplum with Hawk, and what I get for free is that it runs on Hadoop.
It runs on Hadoop, exactly.
Right. So
exactly.
my migration from a traditional MPP database with Greenplum that I maybe have to Hadoop could be absolutely pain-free.
Absolutely pain-free.
Like I just basically replace this and I'm done. And then I have the opportunity to do all that magic stuff.
Right.
But boom, it's there.
Yeah. So
That's cool.
even with this though, because of HDFS's semantics and limitations on in-place updates, etc. So we had to drop a few pieces from Greenplum database to get this working.
Okay.
So we used to have a table called the heap table, which would actually organize the tables in a classic B plus tree, right? And managing B plus trees on HDFS is pain, to say the least. So that is why we moved to the whole append-only tables.
Yeah.
But the execution engine essentially remains identical.
Okay.
And then we have a project that was going on for almost 4 years now with UC Berkeley and several other universities for a package of machine learning libraries called MadLib. So that runs inside of the Hawk.
Oh,
right?
okay.
So Hawk is basically execution engine plus a bunch of UDFs, PLR, all the UDFs written in various languages, plus MadLib. Okay, so that's sort of for the analytics use cases.
So the only thing if I replace my Greenplum with Hawk and have Hadoop basically for free in there, the only thing I'm kind of losing or what I have to move to is append-only tables.
Yes, that's right.
You will have that anyhow with Hadoop. Right?
That is correct.
But all my ETL infrastructure, my
Everything
analytics infrastructure, everything just works.
Yeah, absolutely.
Right? I basically do the trick where someone has all the Chinese on the table and you just pull out the thing and it's still right there.
Absolutely.
That's cool.
Yeah. So over the last year, since Greenplum and various properties or various projects from VMware also merged into Pivotal, we ported Gemfire, which is actually the SQL Fire part of Gemfire with the SQL query interface, and that is rebranded as Gemfire XD. So what Gemfire XD is basically an in-memory data store with a SQL query engine. Okay, so these are the two components that are sort of a special sauce in our Pivotal Hadoop distribution, which are not available from elsewhere. But the rest of the things, if you want to just use Pivotal Hadoop distribution for running your MapReduce and Hive, yes, you can do that too.
So I have I get kind of an SAP HANA that sits on top of a freaking fast Greenplum, and I get the Hadoop under, and I basically leave everything as is with my whole infrastructure. And instead of writing into Greenplum tables now for free, I get Hawk tables on HDFS, and that's Parquet, as you said earlier.
It is now with the Hadoop 2.0. In the PhD or Pivotal Hadoop 2.0, it's Parquet.
So it's Parquet, and then I can use every MapReduce kind of framework, like Mahout, to go against Park.
Yeah, absolutely. Absolutely, right. But there's only one correction that I would like to make, right? Gemfire XD is actually optimized for gets and puts.
Okay.
Unlike SAP HANA, HANA from its beginning was engineered to be for what they call as the OLAP, online everything processing. So OLTP and OLAP combined, right? So it is actually much more efficient, I think, based on all the reports that I've heard, to do scan-based workloads in SAP HANA. Whereas the points, gets, and the rapid data ingestion as well as point gets and puts actually are pretty well optimized in Gemfire XD.
Okay, what's kind of more critical in that environment anyhow, right?
Exactly, because the scan-based workloads, when you're scanning large amounts of data, we already have a product which is optimized for that. Yeah, exactly. So that's what the entire Pivotal HD looks like. Now, on the top, we basically are working on a project called Spring XD, and Spring XD is since you have worked with Spring, it's basically Spring Data, Spring Integration, and Spring Batch with plugins for Hadoop and everything else.
So I write a Spring application and I basically write to Hibernate or to Gemfire?
Yes, exactly.
Jeez.
Exactly. That's basically the whole goal. Now, Spring XD is, I think, at what we call as the release candidate 6. So it's not yet GA. but soon, I think by the end of this year, it should be GA.
Can I just take my Spring application that by today writes in an RDBMS and put your framework under, and I'm
absolutely.
done? And then
Absolutely.
it writes into Hadoop, but I also have the performance to pull out because
Exactly.
of the
So
memory piece?
both of these have JDBC drivers. Both Hawk as well as Gemfire XD have JDBC drivers, right? And the data, when it gets retired from Gemfire XD, actually lands in HDFS so that it can be ingested back into Hawk as well. So
that
all
makes a really strong enterprise application, data-driven enterprise application story where you guys say, you have your Spring application or you have your environment that's already there, and by the way, we do the tablecloth trick where you just replace it and nobody even notices it.
Yeah,
great.
That's basically the thing. And you'll basically see, more things here. So GraphLab, OpenMPI, all these things, Spark in future, you'll see it there.
Come there.
Yeah.
In your own words, the customers of the Pivotal, what is the reason they're going for Pivotal?
I think the main reason that they are going for Pivotal, actually there are three main reasons now, because also Hawk, Gemfire XD, that came out recently. So this is the main reason.
Yeah.
And the second one is our support pedigree from EMC.
Right.
A lot of our support
You might
actually,
did that before. It's not
we
you building
actually
a new
had that
company.
before. Yeah, exactly.
You
Right.
did enterprise software,
being part of EMC, the Greenplum in particular was part of EMC. Actually, a lot of support people have come from that, support grind of EMC. So that whole
you can call them at 2 a.m.
You call them
they
at 2
pick
a.m.
up.
Yeah.
Good.
You can call the execs at 2 a.m. and they will wake up people. That's how it has worked sometimes. Yeah, absolutely.
All right, I want to have that phone number.